Um, week 8. Is it today? I'm supposed to give you guys the assignment. Let me double check. Is it today? Not so sure. Did you all have breakfast? A bit late, isn't it? Not yet, Farah. Yeah, I'm having mine now, but just now I was having mine. So when I check your week 9, not this week. So I was a bit worried. It's this week. It's for the other courses apparently. Not for you guys. You guys next week for your assignment. So that's okay. First midterm coursework. Yeah. And I believe we have finished chapter 4, and we're going to start chapter 5 today. Yeah. So how was your weekend? Was it okay? I'm getting a bit of a sore throat, perhaps because I was having a restless sleep last night. Couldn't sleep. I don't know why. So a bit tired feeling, but should be okay to conduct classes. So how was your weekend? Was it okay?
Okay.
Busy weekend, is it?
Oh yeah.
Oh yeah.
Right.
Okay. Why busy? I mean, you're getting your assignment, is it, from other subjects?
Oh yeah.
Oh yeah. Yeah. School started to reopen today. The whole primary school, is it, going back to school? So cannot imagine how it's going to be like. All the SOPs and stuff. And we're due to go back sometime in May, I think. Yeah. So hopefully all is good, yeah, for us to go back by May. Some universities they already started, receiving back students, especially the ones that require usage of the labs and mock room and stuff. So without wasting any more time, is there any question from anyone? Any question you'd like to raise up?
No.
No. No. So let's start the session for today. So I'm going to start my recording, yeah? Hello, good morning. Today is the 8th of March. Yeah, how time flies. I thought I've already present my screen. Apparently not. So let me present my screen. And this is what we're going to do today. Yeah. Uh, it's a Monday morning, 8th of March 2021. It's week 8 of academic semester 202101. Yeah, and we are doing chapter 5, which is called estimation for the subject BAMS 1613, probability and statistics. What you see here, chapter 5 here, it's written there as estimation only. Yeah, we're going to do the first part of chapter 5 because chapter 5 is quite lengthy. you have estimation, and the other one is called the hypothesis testing. Yeah. Um, I hope this is the part where I'm supposed to start today. I remember clearly that I've completed chapter 4 last week. So today we're starting off with estimation. I am correct, right? Just to verify with everyone again. Yes?
Oh yeah.
Okay, good. Yeah. So yeah, what is chapter 5 about? Again, this topic I would consider new for diploma students because for them they are fresh from SPM. But for you guys, I'm not so sure how or did you learn about estimation during your diploma or foundation studies. Yeah. So let me know if you had studied before. If not, then I hope I can share as much as possible so that you'll be able to understand this topic clearly. Yeah. Um, if I compare with the other courses for this topic, you are actually learning much lesser in terms of the coverage because for the other batch of students, especially the business students, they do another topic under this chapter 5, which is called the chi square. But for your group, yeah, for computing students, we do not cover that in the chi-square test. What you will cover is this one, which is the estimation, and another area which is called the hypothesis testing. So those are the two areas which I normally consider it's a new topic for most students. Yeah, because I know for a fact that in SPM high school you do not cover. But then again, it depends whether it was covered during your studies. Have you ever done hypothesis testing and estimation before? Anyone? Calvin, Noel, and Sarah?
No.
Sorry.
No.
No.
I see. Okay. So what is it about? Yeah. So let us check it out.
No.
Now, first of all, before we go into in detail about what this estimation is about, we look first the idea of sampling theory. Sampling theory is basically we are studying what is the relationship between a population and a sample which you have taken from basically a population. Yeah, and it is useful in the following aspect of statistics in such that say we have the population mean and variance, we want to look into the estimation of unknown population parameters, like what I said just now in terms of population mean and variance, from a knowledge of corresponding sample statistics. So it goes back to when we were learning in chapter 1 about population and sample. You see, for us to do a survey or a study on the population, it is a very big data. Yeah. And normally researchers or anybody's doing any kind of study, they would not go for population, meaning each and every item in that population are being considered. That would be very costly and time consuming. So because of that, we have to refer on all the samples. So any related samples are used in order to make an estimation of the population. It is more time, allowing us to have more time, and of course, less cost to do that. Yeah. So basically, here, that's what we do. we have a few samples given to us, and from that sample, it is hoped we are able to estimate what is the population, the information about the population. Of course, we're not going to do I click well, like real actual research. It's just that what you will be getting are questions which you have to do a bit of calculation and derive the conclusion. Yeah. Um, in this area of estimation, first one, we're going to look at um, confidence interval first. That's a term that you need to be familiar with. And then later on, the second part, then you look into the hypothesis testing, which hypothesis testing is in reference to the significance level that is provided. So it depends on how many significance level that is given. In actuality, the significance level is basically the error or the how many percent that it doesn't meet to the um, accurateness of the answer. Yeah, so always when we're doing hypothesis testing, kind of question, the keyword is significant level. Yeah, how do you identify that that question needs to be solved using hypothesis testing method? The keyword is the word significance level will definitely be given to you. And the significant level is not big, it's normally less than 10%. It could be 5%, it could be 2%, it could be 1%, depending on the question that is given to you. But if you're doing an actual survey, that one you have to decide on your own, depending on what kind of data you are doing your research on, and many other constraints that has to be considered. So you see, researchers or people who are doing any kind of study, yeah, they do use this type of calculation, hypothesis testing, but because of the huge data that they are dealing with, therefore um, most of the time they don't calculate it manually. We have a software tools, a statistical tool now that is available to be used. So the data you just have to input on the software, and then you can derive all sorts of statistical calculation from it as long as you have input the data accordingly. Yeah. But for us, of course, we do not, our course here, we do not require to use statistical tool in our calculation because the questions that we are going to do are mainly very simple, direct question, which we just need to understand how to do the calculation. Okay, so that is why for this subject we do not have to use the statistical tools. But perhaps when you start doing your project, you might have to to consider usage of the statistical tool in order to get your result. Yeah. Um, Now, when we're doing the sampling distribution, what we do here is we will consider all possible samples of size n, which can be drawn from a given population. So you see, all possible samples of size n. That means there are several samples, and these samples, it is hoped, um, well, it is obtained from the population, and from each of the sample, we can basically calculate the simple statistics that we have learned before, like in chapter 2, the calculation of the mean, variance, standard deviation, and all the rest, which of definitely will be different from each sample. Now, remember, from the population, it doesn't mean you take only one sample, you take several samples. And definitely, it is very impossible that the samples are equal. They are definitely going to give you different values of the mean, different values of the standard deviation. So, in such, you have sort of like a statistics of different samples. Now, from here, we can obtain a distribution of the statistics, which we call it as sampling distribution. Now, an example of a sampling distribution is the sampling distribution of sample mean, and number two is the sampling distribution of sample proportion. So these are the two things we're going to use. Yeah. First one is the sample mean, and second one is the sample proportion. Yeah. And the first one we're going to do is the sampling distribution of sample means from a normal population. What it says here is that if you have x1, x2 up to xn, that means many random sample of size n, which is taken from a normal distribution. We have obtained the mean of the data. That means we have the mean labeled as mu and the variance labeled as sigma squared. But as you know, variance we don't really use in the calculation. We use the standard deviation basically. So it's basically just the sigma,
Sigma.
such that x follows a normal distribution, of which we have the mu and the variance. Then we can say the distribution of x bar, which is, as you can see, there is a difference now. Here there is no bar, but when we denote x bar here, it is also a normal distribution, but now take note, the x bar follows the normal with the mean, no change, but the variance we have to divide by n. Now this is for the cases when the x bar is equal to adding up all the random sample of size n, x1 until xn, and divide by how many, what is the sample size of that particular distribution, all the different distribution. So with this, from here, we can basically see that because we don't use the variance, we use the standard deviation. You can see that once we take only the standard deviation, the n here is therefore have to be square root, because when you square root this, because we don't want to use the squared, of course here also use square root, right? So that is why we have this as the standard error of the mean. Yeah. So always remember now, in the calculation of this, yeah, the sampling distribution of sample means, of which we obtain from a normal population, the standard deviation now, instead of just using the standard deviation value in the calculation, yeah, in the calculation to derive how many percentage, yeah, now we have to divide the standard deviation with square root of n, you know, depending on what is the size of your sample. So any questions so far, class?
No.
No. All clear, is it?
Yes.
I hope so. Okay. Now, let me show you the first example. Now, the first example, you can see the sample size is 15. That is your n. And it is stated here it's taken from a normal distribution whereby the mean is 60 and the standard deviation is 4. So all the information are given to you. This is the kind of question you would expect. And the question is asking us to find the probability that the mean of the sample is less than 58. Yeah. So for this kind of question, yeah, um, we are to find the probability of the mean of the sample is therefore first you must state that x is equivalent to the variable of population, because it doesn't, in this question it didn't state what is the actual random variable is about, so we just say it as a variable of a population. And listing out all the information that is provided to us, you have the mean equals to 60, yeah, and the standard deviation given to you as 4, and your n is equal to 15. So from here we can say that x is following a normal distribution with mean and the sigma squared as your variance. Therefore, we can say that it follows a sample mean with x bar follows a normal. The mean remains the same, but now the standard deviation, or the variance for that matter, is now must be divided with the number of the sample. So you see here, what happens here now is that the mean still remain the same as 60. Yeah, x mu x bar equals to mu equals to 60. But now the standard deviation of the sample mean is now we have to divide by the number of sample given. So that means the standard deviation you divide by the square root 15, and that gives you 1.0328. Yeah, so if you use your calculator and you calculate that, you get 1.0328. Yeah, so based on what we have learned last time concerning with normal distribution, what we do in order to find a sample that is less than 58, that means we want the probability of x less than 58. Yeah, so notice here p probability of x bar, that means we want to find out the sample mean less than 58, is therefore we just standardize it. That means the sample mean minus with the mu, and now this time slightly different in the standardization process. The sigma you must divide by square root n. And we already calculated that, yeah? We have 1.0328. And therefore you just deduct 58 minus 60, divide by the value, and that gives us probability of z less than negative 1.94. So if you recall, if you have a negative area from the normal distribution, and in this question we want less than negative 1.94, that means all the area here, yeah, and therefore we have to do the symmetrical of it, the calculation of the symmetrical to it. That means now it will be on the positive side, and symmetrical to it would be on this side. So it's not difficult to calculate. We can straight away refer to the table, which is probability of z greater than 1.94, because they are symmetrical, they are the same. So you just need to check from the table, and that would give you 0.0262. Can you validate the answer? Correct? Should be. Yeah?
Bueno. Oh yeah.
It is correct, right?
Oh yeah.
Okay. So any question on this? Do you understand? Any
A
question,
bit no.
anybody? No question?
No.
Okay. Let me know if you have any question, yeah? So quite simple. It's similar to normal distribution. It's just that we have to do the standard error. And when I say standard error, it's basically this calculation here. Yeah? That means the sigma or the standard deviation you must divide by the square root of the number of sample. So if no
Miss,
question, oh yeah,
if
any question?
how to know if to if use this formula?
Mm, how to know? Hang on. Normally, for this kind of question, you see the word mean of the sample. You see here, mean of the sample. That would give you a clue of that this question is requiring you to find the sample mean. You see
Oh,
this mean of the sample. Yeah.
okay.
Okay. All right. Okay. The next one is another example, and as you can see again, yeah. Noel, just to highlight it to you, you see the sample means. Yeah. What proportion of the sample mean? So in this case, it doesn't ask for percentage; it asks for proportion. Yeah. So that means we don't have to leave the answer in percentage, just like what we did in this example. Example one, we didn't, convert it to percentage. So in this example, we have the mean is 8 and the standard deviation is 2. It's normally distributed. We have a sample of 25 calls. What proportion of the sample mean? So in this case, we have 7.8 and 8.2 minutes, and the other one is 7.5 and 8 minutes. So we do the same thing. Let x be equivalent to the duration of long distance telephone calls. Yeah. And we jot down all the information provided. The mean is 8, the standard deviation is 2, and the n is 25. So therefore, we do know that x follows a normal with the mean and the variance. Therefore, for the sample mean, it follows the normal with the mean x bar, the mean sample mean, and the variance also with the sample mean. Yeah. So because of that, we therefore have the mu still the same value. However, the um, standard deviation now, or rather we're finding the standard error. That means the value 2, you need to divide by square root 25. So that gives you a zero point 0.4. Yeah? Is that understood?
Okay.
So, so the calculation is therefore this. Yeah, you just have to put all the values, standardize it. You can see the middle part here is where now there is a change in terms of standardization. We have to find the standard error. Yeah, the standard deviation divided by square root n. So same goes for 7.8 to 8.2 and 7.5 to the value of 8. So when you do this, you have the values as negative 0.5 to 0.5. And of course, here you have one part positive, one part negative. So it's best to use the total value 1. You minus 2 of the symmetrical of z greater than 0.5 because they are symmetrical, right? So you can times 2. And what you need to do now is just to get the values from the table for z greater than 0.5. And you get 1 minus 2 times 0.3085, and therefore 0.303. Is that correct? Yes.
Wait.
Okay, the next one would be the same thing.
Miss, the second line.
I can't hear you, Noel.
The second line. The A.
Here,
No,
this
up there
one,
again. Up
this
there.
one, here.
Yeah. If like
Oh,
instead of writing the formula, if I write the Z only, can.
oh, yes, of course you can. I mean, you don't want to write this gun, it's okay. Doesn't matter.
Oh, okay.
Yeah. Did you get the same answer? Or is this answer provided in your notes?
I don't have.
Huh?
I don't have.
I can't hear you, Noel.
Don't have the answer.
Don't have the answer, is it? Or so I hope you know how to calculate this and get the same answer. Let me know if my answer is incorrect because sometimes I might have typed it incorrectly. Yeah. So if and then if you don't understand certain parts, let me know so that I can explain it further. Okay, the next part is 7.5 to 8. And when you calculate it, standardize it, you'd get negative 1.25 to 0. And symmetrical, because instead of using the negative, you can do it the other way around. Maybe I draw the diagram here just to illustrate to everyone. So you see the original question is from negative 1.25 to the value of 0. So this is what we want. But of course, in order to answer it, it would be best to use symmetrical as in 1.25 positive now. And this is the area we're referring to, yeah, in the red. So the reason why I use zero point 0.5 here, just in case you're not sure why, is because I'm considering all this area here, the whole area here, which we know is zero point 0.5, minus the small portion that is the balance of 1.25, which as you can see, what has been written here. So zero point 0.5, and you check the value of z greater than 1.25 from the table, that gives you 0.1056, and therefore calculating that, that would give you 0.394. Yeah. Any question, anybody?
No.
Sarah, okay. I think I remember Farah said his microphone not working. Mm-hmm. I hope Kelvin is okay as well.
Okay.
Okay, so quite straightforward, right? Now we go on to sampling distribution of sample means from any population, such that we are more focused in this particular area now, based on the two examples that was discussed just now. Now we come into what we call as the central limit theorem. What does it mean? It's the same thing as what we have done just now. It's just that now it's official that you know what is central limit theorem. That is, if x1, x2 up to xn is a random sample of size n from any distribution with the mean mu and the variance sigma squared, then for large n, yeah, the distribution of sample mean x bar is approximately normal, and x follows a normal, which is what we have covered just now, where x, the sample mean, yeah, x bar here, is equal to 1 over n times with all the random sample x1, x2 up to xn. Now do take note, what do we consider as large here is that when the sample size is large, is that when the n is equal to 30 or greater. Yeah, so it's considered large lah whenever in the question you are given n which is greater than 30. Yeah, so this is an example. Yep, and what we have here, a random sample of size 30 is taken from a population. Find the probability that the sample mean exceeds 5. That means more than 5. So we have two questions here. The first one is x follows a Poisson and therefore your mean is 4.5, that is your lambda. The second question is x follows a binomial and we have 9 as your n and 0.5 as your p. Now solving question A first. Say we have, not say, we are given with n equals 30 and the lambda is 4.5 as given here. Now what we have here, the n is equal to 30 and by the central limit theorem, yeah, it stated that the sample mean follows a normal whereby your mean is from the sample mean and your variance is based on sample mean approximately. So in this case, we can therefore take that the mean, the mean, the sample mean, yeah, is equal to mu is equal to 4.5 because our lambda is of course equal to mean if you remember what we covered last time. And therefore, our standard deviation is square root 4.5 because remember, when we want to find the standard deviation from the Poisson, the lambda, you have to square root it. And based on the formula of the central, not the standard error, the n we have to square root. So that's why you see here the 4.5, which is the lambda, we square root it in order to find the standard deviation and divide by the square root 30, which is your sample size. So when you calculate that, that would give you 0.3873, and therefore, in order to calculate the mean exceed 5, that means it's greater than 5. Notice that I'm using probability of x bar, the sample mean is greater than 5. So from here, we have z greater than 5 minus 4.5, standardizing it, and divide by the value that we have calculated. So from here, what we got is probability of z greater than 1.29, and of course this value you can straight away check on the table, and that would give you 0.0985. So I hope you have the table in front of you and you're doing the checking as well. Is that okay? Any question?
No.
No question.
The standard deviation and the oh,
Sorry, Helwig, I didn't get you.
why they give the standard deviation?
Why they get the standard
Oh,
deviation?
I mean, no, oh, never mind.
Hmm?
That is that the 4.5 the standard deviation?
Yeah, because if you remember a Poisson, from a Poisson to normal, we have lambda is the mean, but if you want to get the standard deviation, you just square root the lambda. Yeah. Today the boy is extremely excited. Remember the boy near my house? Is it very clear for you to hear, or do you, because I've turned off the background noises, can you hear the child?
Crying. No, no, I don't.
You can hear or cannot?
Cannot.
Oh, so it's okay lah. Because I didn't turn on the aircon. It's a bit cold, I feel still. So I opened the window, so it's a bit noisy for me. But I hope it doesn't disturb you guys. So any other question from here? Is it clear? Is it understood? Like what I've answered to Noel earlier, you might be, wondering why do we have to do a bit of adjustment? It's still a standard deviation kind. No, it's still like a normal distribution kind of question, but the word sample mean here makes the whole difference. Yeah, and remember that when I was starting explaining to you about this estimation, these are basically um, taken from samples, and we use this to estimate the population. Yeah, um, and from the answer that we obtain from the sample mean, we it is considered a valid value to make an estimation out of the population. Yeah, because we have several information concerning from the sample, and since the sample does come from the population, it is possible for us to make a conclusion in that sense. Yeah. So we move on to the part B, whereby here it's a binomial, and of course we have to calculate the mean, which is from the binomial you just multiply n times p, you get 4.5, and the variance is npq, and your q is 1 minus p, isn't it? So since your p is 0.5, your q would also be 0.5. So when you calculate that, you get 2.25. And of course, now our standard error is the value of 2.25 square rooted, because that's the value of the variance. For standard deviation, you have to square root it, and then your n, which is 30, square root it as well. You get 0.2739. And by the central limit theorem, we therefore have the sample mean follows a normal, of which your mean, sample mean, is 4.5, and sample standard deviation, or in this case, it's still in the form of a variance, 2.25 squared approximately. So, did I write that correctly? Well, anyhow, when we calculate it, the question asks for probability of x, the sample mean, x bar is greater than 5, exceed 5, remember? So here, standardizing it, we get z greater than 5.5 minus 4.5. This is correct. Yes, and this is correct. I was worried about this value though, um, because it's not totally correct. But it's still a representation of the. I'm concerned about this because this is the variance. Well, anyhow, the correct value has been used here. We should use the 0.2739. So everything here we divide by 0.2739, and therefore calculating that you get z greater than 1.83, and therefore well, this one you can straight away check from the table, isn't it? So that gives you 0.0336 as your answer. Any question, anybody? Is it clear?
Also, the 2.25 squared is not supposed to be there,
Yeah,
is it?
I think it should be a different value. Hang on, let me, really think about it first, because by right, in terms of the central limit theorem, Well, hang on. Let me go back to, should I go back to the slide? Because I just want to verify the calculation is correct already, but in terms of the central limit theorem, it doesn't say here, yeah. Mm, I just want to make sure that we have written correctly, and you can see from here, mm, at least you have divided by n lah. When you're writing this notation, it follows the sample mean. The mean is still the same, but the sigma squared divided by n. So if I go back to what we covered just now, same thing here, kan? But this one, I didn't write the notation, isn't it? But here I did write the notation by the central limit theorem. It's just the standard deviation. We haven't done the standard error edit of it at all, because here you can see the calculation has been calculated. I'm just concerned about about this part. My voice is of writing it down. So based on the notes, it was written as sigma squared divided by n. So sigma squared 2.25 divided by 30. Is it the same value? Let me just double check. No, it's not. Yeah. Hmm. I think it should be alright because it's the value of the variance, right? When you write it down. So don't worry, cause it should be okay. I'm the one who got worried about it. Um, Let me think about it. Yeah. 2.25 is the value of the variance. Because now, in terms of the notation, I'm thinking of whether you should put the no. Yeah, that is correct. Sorry, class, about that. Why should we write divide by the only when we start doing the calculation of it, then we divide the square root 30, this part. So this should be correct already. Okay.
So the previous formula where the uh, standard deviation divided by n cannot be used. Is that
You mean like this one? The
the
one
one?
in the calculation we use this, of course. Of course, in the calculation we use 0.2739. But I'm talking about the notation here, whether you should write 2.25 squared, which is the variance, yeah, of this particular question now. This is the variance. I was thinking of should we write the square root like this, but like do we need to write over and then 30 here? But I remember there was one example, it was written, yes or not? Was it earlier when we did it earlier? Let me just double check. No, it was not written. It's still just the standard deviation because that is assuming we haven't. But by right, it's already
Oh,
standardized. Hang on, let me just double check if my notation is correct. Yeah, it's just the variance. Only when you start doing the calculation, then you do this lah. You divide by the sample. Yeah, so it's correct. I'm getting confused myself. So
oh,
here, what you see here, Then I see this one again. Ah, you see this part? This is what makes me confused, class. This part. But this one is not the sample mean because it has no
This one
bar
the
on top.
binomial, right? This one, the
Yeah,
previous.
binomial. Um, there, by the central here bar, you can see x bar follows a normal. When you state it, it's simply the variance. No need to divide by the square root 30. So it's correct. Sorry about that, class. A bit of confusion. Therefore, this is correct already. What is being written, and it's meaning when you write the x bar, the sample mean follows a normal. You have the value of the mean and just write the value of the variance here, which we got the variance as 2.25, right? Just write 2.25 squared. No need to divide by 30, yeah, because that would give us a different value. When we calculate it, then we use the one that has been divided by square root 30, square root n, that is. Yeah, okay. Is that clear?
Okay.
Okay, so I hope everybody is okay. So yeah, after covering this, I think this is a good time for a short break. Can we continue at 5 minutes after a short break? Yeah?
Okay. Okay.
Okay, see you guys in a bit. Okay, hello, welcome back. I hope everybody is back.
Hello.
Okay. We're going to do next what we call as the sampling distribution of sample proportions. Yeah, just now was the sample mean, so this time is sample proportion. So now instead of focusing on the mean, we are focusing on the p, which is the proportion. So we do consider the p here as the proportion of successes in the sample. Yeah, and for any sample of size n, of which it is taken from a population, and we use x here as the random variable to denote the number of successes in the sample. Yeah, and therefore, for any distribution x follows a binomial with n and p, and for cases when the n is large, hence we have x follows a normal, of which np as the mean and npq is the standard deviation approximately. Yeah, that we have covered previously. So in this case, we are going to use ps, yeah, is the random variable of the proportion of successes in a sample, of which we write it as p is obtainable from x divided by n. That means the x here refers to what is the number of successes from the n, the sample given. So the mean of the proportion, sample proportion, is the value of the p, and the variance of the sample proportion is obtained from p times 1 minus p divided by n. So once you identify what is your mean and what is your variance, of course, it is possible for us to do the calculation already. Yeah. So with that, this is the notation of the sample proportion. Instead of like just now we're doing the sample mean, you have x with a bar on top. That is the sample mean. For the sample proportion, this is the notation we use. Follows the normal. The p is the mean, and this formula, as what is given to you here, is the variance. So a bit of note here to take note, of course. The larger the sample size, the better the approximation. So, um, of course, a bigger sample size provided to us that would give us a better result. Yeah. The distribution on the sample proportion, well, this one it's known as sampling distribution of proportion. That is a full name to it, and the standard error is this value. Just like when we did the sample mean, we did identify what is the standard error of the mean. Yeah. So this is considered as the standard error of the proportion. Just to take note, just in case, sometimes the question they might ask you to state what is the standard error for mean or what is the standard error for proportion. Just make sure you know. Okay, so we go into, oops, I didn't show you an example, did I? Oh dear, there's supposed to be some example. Hang on, I might have one or two here which I can share with you guys. Because I think, yeah, this is the one. So let me slide through it. I don't think you have this example in your notes. I don't think so. I did go through your notes last night and checking, and apparently this is not. So let me just share with you guys. This is about the 2% of the trees in a plantation are known to have a certain disease. What is the probability that in a sample of 300 trees? Now, a bit vague this question because it doesn't say find the sample proportion, yes or no? Because remember in the example in the past, the one that I gave you earlier, um, the question is included with the word sample mean, but this one is not very direct. They just give us the percentage, 2%, and your n is 300, is what you see here. Yeah, but basically this question is also asking us to find the sample proportion. So you have two types. One is more than 4%, the other that is less than 1% are disease. Yeah. So what we have in order to solve this, we let P be equivalent to sample proportion of trees which are diseased. So from the information we obtained from the question, our P is 2%, which indicates to us that the P is 0.02 and the N is 300. So notice that the N is very, very big. Yes or not, class? So P follows an N with the mean P. Um, yeah, this one I should be very careful when I write this because it should be the proportion, right? But I still use the mu, so that might confuse students a bit. But basically, yeah, okay, yeah. Therefore, we have to change it to mu p, mean of the proportion, which is the p is 0.02. I thought I didn't include this. And the standard error for the proportion is therefore we put it into this formula, and when you calculate it, you get 0.0081. Yeah, 0.02 times with 0.98 divided by 300, you get 0.0081. So once we have obtained that, then we just have to put it into the formula, because the first question is asking for the uh, probability of greater than 4%. Of course, that refers to 0.04. You standardize it, minus with the proportion, and then divide by the, well, minus with the mean in terms of the sample proportion and divide by the standard deviation or standard error for the proportion. And calculating that, you get 2.47, and that gives us from the table 0.00676. Same goes with the 1%, less than 1%, standardize it, and therefore you get Z less than negative 1.234. And of course, this we cannot calculate for negative, we have to use symmetrical, and that means we need to find Z greater than 1.234. Of course, in your table, you cannot find three digits, right? Three decimal places. So we just take 1.23 up to two decimal places based on the table that we have, and therefore our answer is 0.1093. Any question, class?
No.
Yeah. How about Sarah and no Calvin? Okay.
It's the need to be very clear if it's sample or population.
Sorry, I didn't get you.
Is the you have to check if it's sample or population first before doing.
Correct. Yeah, you have to check whether it's the sample mean kind of question or sample proportion kind of question. So need to be very extra careful when you're reading the question. Yeah. But basically, the coverage of this part is not that difficult. It's quite straightforward. It's simply the calculation, as what you have seen. It's the difference is, well, basically the mean is almost the same value. The only area you need to be careful of is the sample. No, the standard error for each sample mean and sample proportion. Yeah, what is the standard error? And that you have to calculate it carefully because at times the value are quite small, so have to be very careful about that. Yeah, so this is the extra example which I don't have, which I think you don't have in your notes. So let me just we still got time. In fact, we got about 45 minutes or so. Yeah. So let me just go to the next slide. I mean the next file. So give me a few minutes to change my file, and I will share and we'll continue. Yeah. Give me a few minutes, like perhaps until 10:20. See you in a bit. Okay. Yeah, this is the next part. Um, I'm worried I'm going a bit too fast, but I think it should be okay. When I check the form B of our costs. progress week by week, we are okay. By right, this one I should cover it next week, but never mind. We just continue. Okay. This is chapter 5, still under chapter 5 here, class. And the next area we're going to cover is called the confidence interval. So just now was just the estimation, which we look at the standard error for both the sample mean and sample proportion. Now we look at what we call as the confidence interval. And for the estimation of the parameters, it's still the same idea that we're using a statistical technique. We want to estimate the population based on the sample. So we have several sample statistics, which we using it will be able to know what is the population. Yeah, and basically all this estimation procedure of the population, um, it start off by following all these steps. Yeah, what we have to do first of all is to select a sample and then collect the required information based on what your research is about. Yeah, you collect the information from the sample, and then you start to calculate the sample statistics, and from there you'll be able to assign values to the corresponding population parameters. But of course, for our case, yeah, we don't do this. We're not doing sort of like a project. Yeah. And I bet your project would be more on the programming side rather than the statistical calculation. Only if you're doing, a maths major, you'd have to do this in depth. And also, I bet the business students would have, if like they're doing a project-based work, then they would have to do something like this, like select a sample, send out questionnaires or a survey to collect the information. But for us, we don't do this. Yeah, all these are the procedure involved, but we do not do that. We do not go and collect the data because what you get in terms of your assignment, it will be just questions which you have to solve and find the solution to it. Yeah. But this is just to make all of you aware what the procedure involves. So that's why people who has the intention to further the studies and do their masters and PhD, they have to do a lot of detailed work, and that definitely takes time and effort. Yeah. um in the estimation of parameters, therefore, estimate here, what does it refers to, are the values which are assigned to the population parameters based on the sample statistics. What was obtained from the sample statistics is now assigned as your population parameters. Those parameters are used in the calculation to determine your population. And we also have estimator, the sample statistics, which is used to estimate the population parameter. And there are two types. The first one is basically the point estimate. This is similar to what we've done in the previous topic, whereby we have a single number, a single value from the sample statistics, which we use it to estimate the population parameter. Yeah. Few examples are the ones that we've covered: the mean, the sample mean, yeah, the standard deviation, or rather the variance. Variance is what you see here. But basically, we focus on the standard deviation and also the proportion. Yeah. But what we're going to do today is what we call as the interval estimate or confidence interval. So this is the second type of estimates. First estimate was the one that, you've studied this in the first earlier 4 chapters. Yeah. So now we're looking into the interval estimate, or what we call as the confidence interval. In our question, the question tend to use confidence interval rather than interval estimate, but they are the same. Okay, so if the question you see using the word interval estimate, it means we have to find the confidence interval. And what is it about? Yeah, confidence interval is an estimate of the population parameter of which the value of the parameter is in between two numbers. So it's like a range of values. Your mean is not fixed to just one value, like what you see in the point estimate. The mean is fixed, and sometimes business people, yeah, or the decision maker in the organization, it's very hard for them to make a decision with just one point estimate, with just one value. So having a confidence interval is much better, because now the value of the mean does not lie only on one fixed figure, but there is a range. That means there is a lower limit and an upper limit. However, when we consider something like this, definitely there would be errors. Yeah. When you consider something like a range of values, there is a limit and a maximum. Definitely there would be what we call as the range of values. Definitely there would be errors. Yeah. um, it's not perfect, it's not 100%. So in this case, when we're doing the confidence interval, say we have a population with unknown parameter theta, we are able to find the interval A to B, meaning A is the lower limit and B the upper limit, such that the probability of theta between the two range, A as the lower limit and B as the upper limit, it would be equal to 0.95. So in such, what does it mean by 0.95? It means that within the range from the lower limit A to the upper limit B, yeah, the range of A to B, we have a 95% confidence interval for the theta. That means we are confident with the theta, the value that we get from A to B is 95%, um, what is the word? Correct, or 95% suitable, of which, as you know, 95% is not 100%. What is the 5%? The 5% is basically, in a sense, the error that could exist. Yeah. So for this case, when it's stated as 95% confidence interval, it means 0.95 out of 1, yeah, that the probability that the interval it includes. That means it satisfies the parameter theta. Yeah. So here, the depending on how many percent given to you, but we just state it as 100 minus 100 times 1 minus alpha. The alpha means the error. So the 100 in brackets 1 minus alpha percent confidence interval for the population mean, when the population variance sigma squared is known, is given by this formula. Yeah. Um, okay. You see, there's a lot of condition here. You see, in this case, the population mean, when the population variance is known. There are several other cases. There are cases when the population variance is not known, unknown, they say. So if we go in depth into this study, there are a lot of different situations. But for our case, for now, we look at finding the 100 in brackets 1 minus alpha percent confidence interval for the population mean, when the population variance is known. So this is the formula we're going to use. Now remember, um, in this case, we're using the value of the mean, sample mean, and the standard deviation. And also another thing you should take note is the plus minus, which means the minus is for the value of the A and the plus is for the value of the B. So if you expand it, you can see there are two values. One here is a minus and the other one here is a plus. That means the mean is between the two values. So that means the first one here is referring to the A. Second one here is referring to the B. So, oops, two cars. So that what it means here is that I didn't point it out. Yeah, the sigma divided by square root n is the maximum error. We call it as the maximum error for the population for the data as given. So you have it's not new to you. We've done this just now, yes or no? So it's just that the presentation of it now our theta, yeah, the unknown parameter theta, it lies between two values of A and B. And that is we are confident by the percentage that is given to us. How many percent? Is it 95%? Is it 98%? And so forth. So, how do we solve this? And how do you know this question is using the confidence interval? Very easy. The word confidence interval is there. And you see, this is 90% confidence interval. So imagine that the alpha or the error is 10%. Okay. Now, from this question, this is about the mean waiting time of his customers. That means in a bank, we want to check out how long does the customer has to wait. And from a sample of 50 customers, they did the survey and they collected the data for 50 customers that comes in. And when they collect the data, they found out that the mean waiting time is 7.2 minutes. It's a fixed point estimate, 7.2 minutes, let's say. So, in order to check out how many, in this case, we want to check out 90% confidence interval, standard deviation is known to be 5 minutes. We want to find the 90% confidence interval of the mean waiting time for all of the bank's customer. So in this case, in order to solve it, first you need to state the random variable. Mu is the population mean waiting time of customer in minutes because that's what the question is about. List out all the other relevant information. You see the n sample, there are 50. The mean is 7.2 and the standard deviation is a 5. And the alpha, how do we know 0.10 is because it's 90% confidence interval. That means our alpha is 10%. It's 0.10. But in this case, yeah, class, why do we have to divide by 2? You notice here, divide by 2. This is because when you have a normal distribution and we want to check the 90% confidence interval, here, the one that I'm shading now is the 90%. It's the 90%. Yeah. So that gives us a balance. The ones that not shaded is 5%, 10%. And of course, 10%, each side here is a 5%. And this side is also 5%. So that is why the alpha here you have to divide by 2, which gives us 0.05, equivalent to 5%. And therefore, you need to check from the table. And the short table, okay, I've already explained to you about long table and short table. And because we have Z 0.05, you check from the short table and you should get 1.6449. So far clear, class?
Miss, the A,
Yeah. Sorry.
the A, is it fixed 0 0.1?
That is not the A, it's the alpha.
Oh, alpha.
It,
Sorry.
yeah. It's not fixed 0.1. It depends on the question. If you look at this question, yeah, Noel, it is 90%. So 90% out of 100%, the balance is 10%. So that's where the alpha equals to. 10% is 0.10, and we need to divide it by 2. It's not fixed. Sometimes some question would be 98%, some question would be 99%. So you have to be very careful with the question also.
Okay.
Okay. So once you have list out all the values here, then we want to find the 90% confidence interval for the mean is, remember this formula, the one that I shared with you. So putting all the values in like 7.2 plus minus, now we already know what is Z alpha divided by 2. It is 1.6449, and multiply by 5, which is the standard deviation, and divide by square root 50, which is your n. So calculating this, you would get 7.2 plus minus 1.1631. After you calculate these, yeah, you get 1.1631. And remember, 1 you minus, 1 you plus. So you get these values. Now always remember to write the smaller value, which is the one that you minus on the left side, and the value that you plus on the right side. So this, when you calculate, of course, you'll get 6.0369 and 8.3631 minutes as your answer. So you see, class, it's not being rigid by just saying a point estimate of 7.2. That's the mean waiting time of the customers. But now what we have is that we are very confident, 90% confident, that the mean waiting time of the customer is within the range of 6.0369 minutes to 8.3631 minutes. So that is our 90% confidence interval. At least we know we are 90% confidence. 90% confidence is already good, what? Yes or not? That the mean waiting time is not so bad. It's between 6 to 8 minutes. But class, have you ever experienced it? When you go to the bank, you wait for 2 minutes, also you feel like half an hour, isn't it? Yeah, waiting is not a good thing. Right, so any question about this? Is it okay? Did I explain correctly? I mean, any question?
Is it possible there's a question 100% confidence?
No, none, because in real life nothing will be perfect. Yeah, there's no 100%. Definitely will be a bit of error, yeah, because it's not perfect. So
Oh,
the most accurate one is 99%. The standard one is 95. You'll see a lot of research paper, they go for 95%. But then again, yeah, 95% is the standard one. Well, it's more safer in that sense when you take a 95%, because it's more practical. To say 100% level, definitely there would be some consideration of standard error. Yeah, okay. But of course, in order to add to your question and all, of course, they would never ask like 70% confidence interval. That is too big. Yeah, like 30% error is too big. So it will definitely be above, around 90% and above lah, basically, the confidence interval. Because what organization would want to consider lesser than 90%? You would want a higher standard, yes or no? So it would be the smallest that I've seen is 90%. Not like this example. Yeah, in terms of your exam question, or your assignment question, it would definitely be above 90%, 90 or above. So I hope that is clear. I hope that is understood. Is it
Okay.
any question? No question from the rest? Okay, huh? So silence means you're
Need
okay.
to write the minutes.
Oh yeah, of course. Of course, in my notes, maybe some of the solution that I've done, I didn't put it, but it is recommended to write the unit of measurement. As you know, this is in minutes, so definitely uh, do write it. It is required. But just to share with everyone, there are solutions written by students in the past. They didn't put the minutes or the unit of measurement, but I still mark it correct. But that is just to be on the safe side. Yeah, some examiner, when I talk about the examiner, sometimes the marking scheme require student to write the unit of measurement, and if let's say you did not write it, then so sayang lah, the marks have to deduct when you don't write it, because it's the norm is to write it. Yeah, but sometimes it's not being stressed upon by the examiner, so it's still okay. But yeah, if you ask me, I would say yes, it would be recommended to write the minutes. Okay. So, Farah, any question from you? You're okay? Yes. Any question from anyone? Farah? Okay. All right. So this is another example. You can see it's a random sample of 70 students in a large university. So I'm going to go a bit faster here. We'll see. So the mean is 14.3, normally distributed 99%. Yeah. Standard deviation is 4.0. Confidence interval 99% confidence interval. So that's the keyword, class. How you know it's a question on confidence interval? The word is confidence interval. So this is about the time spent doing homework. Yeah. So in order to solve this, we let mu as the sample of mean weekly time spent doing homework in hours. Jot down all the important information like what's your n, what's the mean given to us, 14.3, standard deviation. How many percent? 99%. So that means our alpha is only 1%. And always we have to divide by 2, because as what I've drawn in the diagram just now, a normal distribution, the 99% takes the middle part, so the remainder would be the 1% you divide by 2, you get 0.005. And this is the value you check from the table. You get 2.5758. Okay, so far okay, class?
Okay.
Okay.
Okay, so from here, once you have determined that the 99% confidence interval is for the mean, yeah, is therefore just put all the values in, okay, and do the calculation, and you should get the two values, which is 13.069 and 15.532 hours. So this is roughly the time spent. We are very confident, 99% confident, that instead of having a point estimate of 14.3, we are confident that students spend time doing homework is between 13.069 to 15.523 hours. Yeah. So some business people, yeah, they find having a range of values like this is much easier for them to make decision rather than having the point estimate, which is just one value of the mean, which is rather less, you know, it is more accurate, but it's not flexible. It's so rigid to just one value. And sometimes having this confidence interval in a way, when you present it in this manner, you're able to convince your investors, yeah, by saying 99% confidence interval, yeah, just highlight lah about it. So, okay, any
No, no,
question?
no, no.
No question, huh? So we move on to the next part, estimation of parameters. Okay, now this is the same thing, but it's just that when the sample size n is large, we are saying n is greater than or equal to 30. Then do you notice what is the difference? The difference is now instead of using the sigma, we're using s now. That's the only difference, class, nothing else. Oops. And you can see here, yeah. Now, you might ask me in the previous example that we did. Let me go back to the first example we did. You see here, the n is big, it's 50. Then the second example, the n is 70. Can you see that? So why am I still using sigma? You see, I'm still using sigma. This is because I haven't explained the concept of it yet. Yeah. So now you know that every time when the n is large, meaning if your n is greater than or equal to 30, instead of using sigma, now we are using the s to indicate that the n is larger. So this one you need to be very careful. Check out the question. If your n is more than or equal to 30, instead of using the sigma, make sure you use the s. Yeah, it's just a matter of notation. Your answer will still be correct no matter what because you still use the same value of the standard deviation, isn't it? But in terms of the notation use, you need to be careful about it. So make sure you write s, especially when your n is greater than or equal to 30. Okay. Well, this is because this is the case where you can see here, yeah, the confidence interval depending on how many percent we have. The mu is, or the mean, yeah, when the population variance sigma squared is unknown. So this is how we use the formula, just a notation of the sigma or the s. But of course, this one is the variance is unknown compared to, you know, let me go back here. You can see here the population variance is known. Yeah, so I hope that is clear. All right, so let's look at the example. Wow, it's 10:50 already. So fast. So looking at this example, so I have a random sample of 200 that is huge, and then a mean of 8.24, standard deviation is 0.42. And we have two questions here, 95% and 99% confidence interval. So in this case, um, I'm just showing you the information that we have, put all the values in. And as you can see, the mean, the standard deviation, the alpha, because this is 95%, right? So Divide by 2, you refer to 0.025 that correspond to 1.96 from the short table, okay? And hence the 95% confidence interval for the mean is basically just put it into the formula and you should get the two range of values, which is 8.1818 and 8.2982 millimeter, where you see S over square root n. Okay, any question?
No.
No question. Notice how the S is using, we are using S here. All right. Now, then the other one, which is the 99%, notice the difference here. Hey, hang on. Still the same gun. Oh, yeah. Different already what? Because 99%. So it's 1%. Notice that. So divide by 2, you get 0.005. Check out from the table, it's 2.5758. And again, put into the formula with the new value in. And we got this as the answer. Any question?
Mm, no. Before this, instead of S, is what again?
Come again?
Because now we're using S kan. Before this, we use what again?
Sigma.
Oh, sigma.
Yeah,
Oh,
but because our n is very large, our n is 200, therefore that's why we use S now. Yeah.
okay.
Mm. All right. So there is another example, and you can see our n is 35. So still using S, yeah. Because you see in this question, it doesn't tell us whether the the standard deviation is known or not known. So it's based on the sample, the number of sample to determine whether you use the sigma or you use the S. Okay. So standard deviation is 12, mean weight is 240, and we want to find out 95% confidence interval, and therefore writing all the information in, you can see 95%, 0.05 divided by 2, and then you get 1.96 from the table, the short table, and the 95% confidence interval for the new, just put all the values in. And that's our answer.
The S is number of what again?
Come again?
The S is it? What it means again?
It's the standard deviation. It's just that we use S as instead of the sigma. It's because the n is large. The n is 35, which is more than 30. And that's why we use S. And the reason why we use S is because, like I said, the n is above 30, but in actuality, uh, from the question, it's very difficult for us. It's not stated in the question whether the standard deviation is known or unknown. If it's not unknown, then we use the sigma. But if it's known, we use the S. So definitely to identify the question correctly, we have to use or check what is your n. And in this case, the n is large, more than 30. Therefore, that's why we use S in this case as your standard deviation, as what you see here. Okay,
So
Noel?
the only difference is the symbol only.
The
Change of symbol
difference
from
is
sigma.
change. Yes, it's just a change of symbol. As long as you identify that the n is more than 30, then you would use S lah. Yeah, if it's less, but
Okay.
seldom lah. I see the n is less than 30 in the question. Normally the n is quite big, so it's always using s. But to be on the safe side, check. Be careful about it. If the n is smaller than 30, use sigma lah. Yeah,
Is there a big difference using?
no difference. The answer is the same. It's just a notation symbol. Okay. Okay. Now this next part, I think we'll do it next week. I think it's a good point to stop because it's already 10:56. Unless there's any other question you would like to ask, but I'm stopping the lecture for today. I think we covered quite a lot up to this slide lah. So next week when we have our next lecture, I will start on estimation of parameters for population proportion. But you can, if you got the time to go through them, you'll see that it's quite straightforward also. All right, so I think that's all for today, class. If there's no question, that's it. Thank you very much. I'll see you guys next week. Hey, tomorrow, yeah. I will post on our WhatsApp which question I will ask you to do for next class. Okay,
Okay, miss.
for our tutorial tomorrow. Okay, thank you. Bye bye.
Okay, thank you, miss.
Thank you.